Well, it looks like we're about at the time we should get going. Hello, everyone. Thank you for coming to talk about this. This is me talking about our implementation to better support the Smart on FHIR standard and the US G10 requirements. Hopefully you can all hear me. I really wish I was all there with all of you in Amsterdam, but glad to be able to participate even remotely. Do just a quick presentation or a quick introduction of myself. I've been at Microsoft close to 15 years. I've been working on the FHIR server at Microsoft for close to 4 years now. That's pretty much all there is to know about me. Thought I would just start out with a quick overview of what G10 is. I imagine all of us here at DevDays may have heard of it or know about it, but just to kind of set the context, in the United States, there is a law to help promote access to healthcare data. That's that 21st Century Cures Act. Because of the law, there is a set of rules or set of certification requirements set by the ONC, which is the Office of the National Coordinator, to help make it crystal clear what those access rules should be. And health IT vendors need to meet the requirements to get certified, and that can have big impacts for them. So the certification rules are built on top of FHIR, hooray, that's why we're here, the US Core Implementation Guide and Smart on FHIR. And these certification rules really went into effect just in December, this past December. So there was a lot of interest, as you can imagine, as these went into effect, and a lot of different health IT vendors needed to get on board with this. Also provided is the Inferno test suite, which many of you probably know of as well, to help let you know if you're successfully meeting these requirements. So as this was becoming into effect, we had some gaps in our FHIR server implementation to meet this. And so we wanted to fill in those gaps and try to make sure that anyone building their solution on top of our FHIR server could meet this certification requirement. As we got going, there's roadblocks. A lot of our work was gaps in meeting Smart on FHIR. So we needed to fill those in and improve our implementation of the Smart on FHIR implementation. We also had a couple of difficulties getting the bulk data and export requirements, specifically some encryption requirements around the token. And I just thought I would mention this missing data requirement in US Core, which was also interesting that had an impact on the performance of the server. We'll go through the overview of the implementation and how more specifics on these challenges and how we overcame them. This is just a picture of the overall kind of solution. So at the bottom of this image is the actual kind of out of the box FHIR server that we offer on Azure. And you can see there's a bunch more pieces there. Principally there is that CloudBox Azure API management, which is like a gateway to handle this traffic coming into the FHIR server and these other areas. We needed something that could kind of transform requests to some degree and route requests to different endpoints, depending on exactly what the request was, which is what Azure API management does for us. We had some issues with the scope syntax and with, as I mentioned, the token for bulk export. So API management can override the response coming back and also make changes to the request coming in so that we could handle those different things. This is all in a samples repository, as it's not, I guess, as it is perhaps a solution out of the box. For example, there's the top box there, it says authorize user input UI. So in a standalone launch for Smart on FHIR, right, you might have a patient picker that is displayed. So we wanted to have a complete solution that would pass the tests and demonstrate that we can meet those certification requirements. So we have something like a sample patient picker UI that pops up and other pieces in here which may be replaced in like a real solution. So that's why we refer to this as a sample, but it has the pieces that you would need to meet all the requirements. And we'll talk a little bit more about these different pieces, but we've got a couple of Azure functions to handle things like generating a token with a 384 encryption, which we had an issue with Azure Active Directory. And I know Azure Active Directory is Microsoft, and I'm Microsoft, but I will talk a little bit about some of its failings. Smart on FHIR is built on OAuth 2.0, and of course, Azure Active Directory is an OAuth 2.0 compliant identity provider. So of course, it being in the standards community, we know that every implementation of standards is perfect, has no gaps, and meets it all perfectly, right? Just like every FHIR implementation is perfect. So we did have some gaps, I would say, or some things that didn't match up quite perfectly between Smart and Azure AD. We'll go into a little bit more detail. So one thing that we needed to do was get information to the FHIR server endpoint about the user, not just the user information that comes in the access token, right, like their OID or the authority, but specifically which FHIR resources this person relates to. Right, so there is the idea of a FHIR user claim in the Smart on FHIR specification, and it is specified that this should be available in the ID token if you request it, and the contents of that FHIR user claim should be a FHIR resource that represents this user accessing the FHIR server, which is it's really the information that we needed in order to enforce Smart on FHIR scopes and access restrictions to the data. And the spec, the Smart on FHIR spec, does not specify what kind of information should be coming in the access token. It specifically says that's outside the scope of the spec, and it makes sense, but that you can put information in there that you need to go from the identity provider to the FHIR server. So we decided to put that same FHIR user claim that's optionally, or that should be included in the ID token, also in the access token, so that when that access token comes to the FHIR server to grant authorization to this user, that we'll have that information and we can then restrict access data. So I just quickly wanted to go through an example of what that looks like, right? Before we implemented this, honestly, on our FHIR server, if you had read access to the server, you were authorized to read, you could read everything, all the resources everywhere. There was no restriction about which resources would be available to you. So if you issued a query like this for observations with a link code, you would just get them all, whatever is in the server. But if you're a Smart on FHIR user, right, and we're implementing the Smart on FHIR standard, then you should really only see resources that are available to you as a user. So if you're patient one, then the subset of resources in the server is really all that should come up. So if you issued this query as patient one, and that was your FHIR user claim, right, that intersection between resources available to patient one and the observation query, just where those two overlap, that's what you should get. And we should also enforce Smart on FHIR scopes, like patient/observation read. So in this case, all observations would be available to you, and then we filter it by the code, and it's still available to patient one. So again, you get a response back with the overlap of those two circles. And just as an example, if instead the application you were accessing the FHIR server through had a scope of patient diagnostic report read, then all that scope would limit you only to diagnostic reports really related to patient one. There would be no overlap, right, between your query that you issued and resource available patient one and the diagnostic report, so you get nothing back. So this was an important piece of the gaps that we had, was enforcing this kind of more fine-grained access control of the resources rather than just simply opening them all up. So how we did that to try to make it agnostic to the data layer is that when the FHIR query comes in to the API, we initially parse out the query string into different pieces, and we build an expression tree in memory. And then our data layer implementations are built to interpret that expression tree. So at the expression tree layer, we're able to add the additional restrictions for which patient and which scope should be enforced. And then by the time the expression gets down to the data layer, it's already filtered to the way it should be. So that way the data layer itself will execute that query with all of the restrictions and all of the filtering already needed to be done. And the resultant data that comes back will be appropriate to the user and to the scope. And it can still be done in a performant way. There's really not much performance impact. As I mentioned, Azure Active Directory limitations. The Smart on FHIR scope has a specific syntax for those scopes, right? Patient/resource dot access control. And I should mention this is Smart on FHIR v1. We did start more simply with Smart on FHIR v2 coming as soon as we can get to it. But in any case, these scopes are for Smart on FHIR v1, and we couldn't express those directly in Azure Active Directory. It just didn't allow slashes or asterisks. So we have the patient.all.read, and I'll show that in an app registration. And then that goes back to that Azure API for FHIR, or Azure API management, which translates these scopes back and forth so that the Smart on FHIR client will still get the same syntax that Smart on FHIR requests, and our FHIR server and Azure Active Directory will get the syntax that they understand. And then I mentioned 3D4 encryption. So the bulk data or export implementation guide requires a certain level of encryption for that token because it's multiple patient data being put out. And Active Directory, the way it produces that 384 encryption token wasn't matching what Inferno, the test suite, was looking for. And so we actually have a section in our sample which signs its own token and makes sure it matches exactly what the Inferno test suite was examining. It looks like just in the last couple of days, Active Directory has made some improvements to that, made some changes, and that may go away and dramatically simplify the sample and drop all the need to re-sign tokens, which of course, if you have your own identity provider, you don't want anybody else signing tokens. So it would be a great improvement and simplification as well. Really quick, this is just a sample of what it looks like to register a client application in Azure Active Directory. You can see all those scopes that I mentioned as part of the resource application, which kind of represents your FHIR server in Active Directory. Then when you register a client application, you can pick the ones you want. I should also mention that the example I'm showing here has many different Smart on FHIR scopes with just the same description matching the actual scope text. That can be customized. You don't have to have the full list if your FHIR server doesn't implement them all, or you don't want them all available for client applications, or you need to customize the description text to make it more friendly to an actual end user that's going to see these when they first access the app, and they get that nice pop-up from OAuth 2.0 that says, hey, Smart App 1 wants to have access to patient.all.read. Well, what does that mean? You could replace that and say access records related to you or something like that. And then we have the missing data requirement, right? We have the fact that when there's necessary pieces of information in a FHIR resource that the US core says should be there, and you want to query down that resource and the data is missing, there's a requirement that we should add in this data absent reason to the resource, which was a little different for us. Usually, you send a FHIR resource to our FHIR server, we store it exactly as is, we send it right back to you. It's really almost like a binary blob, right? We put it in there, we send it back. It makes very fast retrieval, and we're making sure we're giving you back the data that we received exactly as it is. But in this case, now we actually need to edit the contents of the FHIR resource. So when you have this requirement enabled, or this behavior enabled to meet this requirement, we've got to examine the contents and then update them to meet this requirement. So it does maybe have a negative performance hit. It was a little maybe surprising we had to do it, I would say, but understandable for the requirement. Yeah, and I think that's really all of the implementation details I wanted to highlight right now. I'll mention that all of the samples with greater detail in the documentation of exactly how they work and what they're doing is out in GitHub. It is an open source sample repository to show all that implementation. And just to wrap it up a bit, our end solution is not just a FHIR server. It has other Azure components wrapped around it to meet the need. The identity provider, in this case, in our case, Azure Active Directory, right, did cause us some difficulties. I just think that might be true for other implementations, right? You can't always choose your identity provider, and it may not exactly meet the specs as they're written. And then I'll just reiterate the fact that we chose to send some information in the access token that's outside the spec. And it does maybe cause a difficulty if you wanted to just swap identity providers, right? You say you don't want Azure Active Directory, or you had the opportunity to change it. In our case, you'd need to make sure to send that FHIR user information active in the access token. The other new identity provider would have to do that. Yeah, so thank you very much. I'm here for Q&As. We've got to the question and answer session.
Thank you, Jared, for your questions. We will start with the questions for the audience that's live, because the online audience can always use their Whova app to place their questions, and then Jared will be able to come back to them. I saw your hand first, sir.
Thank you for a great presentation. This is Amol from NCQA. I had a question about your registration process that you outlined. Is that the same for single patient as well as population API?
It is. Yep, it would be the same exact registration process. I don't have, in the screenshot, I don't have the list for the scopes, but there are more scopes for the bulk patient access as well. And it'd be the same process.
Excellent. As a follow-up, where can I get more information on the actual, I guess, provider or facilities that the registration covers right now? Something like I don't know, maybe a chapel, ONC's chapel list, or kind of a directory. Is that information available?
Yeah, maybe I'm not 100% sure I understand the question. Like, you want more information exactly about like which organization?
The data sources that your G10 solution covers.
Oh, like which FHIR resources are supported, or?
Well, I'm really looking at, when I look at the G10 APIs, I look at, provider facilities having EHR systems that basically expose the API endpoints as far as patients that the facility kind of has. Is there a similar kind of a list of facilities or providers with their endpoints that I can kind of take a look at, and perhaps look at their sandbox to see how their registration process goes, kind of take it for a test ride, if you will?
Yeah. Great question. I mean, in this case, this is kind of the Azure FHIR server that many organizations may then use, but directly, this is not like an implementation that a specific implementation or a specific facility that I'm talking about. So I don't have the list of who's implementing it right now and who is live. Does that make sense?
Yes, thank you.
Yeah, sorry, I don't have more details about that. But.
I have one quick question from the online audience for you, Jared. Is the Azure FHIR server available for US government?
It is, yes. It is in the Gov region.
Well, there you go. Any other questions for the audience here in the room? No?
Yeah.
I guess it was a clear story.
Okay.
If there will be any questions afterwards, you can use, of course, the Whova Q&A, and Jared will be able to answer them.
I do see a couple of questions there in the Whova app.
Yeah.
So.
Oh, right. Oh, then we can go over them.
Yeah, so one is, do you have any CQL component in Azure? No, we don't right now, unfortunately. That's the clinical query language, if I'm getting the acronym correctly. We don't have anything built in at the moment, but I'll take it as a note. And then it says, will you be providing the FHIR auth-z service as a product, say included in your current Azure API FHIR offering, or will it stay open source? We do want to take everything that's in the sample and build it into the managed service. As part, like I said, part of the blocking issues there were some limitations on Azure AD. We're working with them to try to improve that and build out more functionality directly into the service. So our goal is, as time goes on, the quote unquote samples will get smaller and smaller, and the managed service will take on more and more of those features. That's a great question. I think that's all the questions I saw in the Whova chat.
Yes, I think so too. Yeah, we're right on time,
Okay.
1:50. I would like to thank you very much, Jared, for your presentation. And I would like to thank all the attendants for their attention and questions.
Yeah.
So have a good
Thank you all
day.
so much. Bye-bye.